Hey all, welcome back. So, in today's video, we are going to discuss about the very important topic in System Verilog, which is System Verilog Test Bench Architecture. So, today I'm going to discuss about this System Verilog Test Bench Architecture, like briefly, what we are going to do, how are we going to write a code in System Verilog. Okay, so based on that, I'll be explaining this architecture. Actually, how are we going to do the verification in test bench in System Verilog? Okay, so I'll be explaining this test bench architecture with an example for you so that you can easily understand how the working is done here. Okay, so okay, now when we went back to the Verilog, so in Verilog, when you are writing a code and when you are writing a test bench, when you are checking that code, basically what you will do, you will be writing the RTL design. For example, you are designing some sim adder. Okay, some you are designing some 3-bit adder. Okay, so for this 3-bit adder in Verilog, what you will do? You will be writing the RTL code, okay, for this adder, okay, for some logic, and then you will be passing the values from the test bench. So in this test bench in the Verilog, what are the things that you will do? You will first be instantiating this RTL with TB. Is it or not? With DOT instantiation, you will be connecting these two RTL and TB environments. And then what you will be do after DOT instantiation, you will be passing the values within initial and begin. Is it or not? Since this is a 3-bit adder, you will be having like A, B, C. So A, B, C values you will be passing, right? So since A, B, C, so how many values it will be having? It will be having values from 0, 0, 0 to okay 1, 1, 1. So total of 8 possible values for 3-bit adder. Is it or not? Yes. So these 8 possible values you will be manually passing in your test bench in Verilog. And all these values they enter into the RTL and they will be working on it. And then after that, after the logic is worked out, what will happen again in test bench? You will be writing $monitor system task. Is it or not? So now what will this monitor do? It will be monitoring all the output values that are coming from the RTL. So this is what that is happening in Verilog, right? So now when we adapt this same working in the system Verilog also, the same thing is happening. Okay, either it is in Verilog test bench or system Verilog test bench, the happening is same. What is that? The values are or the values are given and then the output will be monitored. Okay, but as I already told you, okay, when you are designing complex circuits, this is not as easy as you think. So, now what happens in order to verify any kind of circuits by using many reusing techniques and by using many advanced features in system Verilog, this architecture is built. Okay, so now let us see what is happening in the system Verilog actually. Now we are taking the same example of 3-bit adder. Okay, in system Verilog. Okay, now we are going to write the test bench architecture for system Verilog. Now what is happening here? So as I already told you, first the generation. Okay, in Verilog you will be generating the values manually. That means you yourself should give the values like a equal to 0, b equal to 0, c equal to 0. Then a equal to 1, b equal to 0, c equal to 0. So in this you should manually give in case of Verilog test bench. Now what happens in system Verilog? You are not going to give, as I already said in the previous video. Okay, in the introduction of SV. If you didn't see that video, I'll link that in the description box. You can go check it out there. So, in the previous session, I already told you that you are not going to queue manually in SV. SV will be generating the values by using some techniques. Okay, so now what happens? The generator is the block. Okay, so whatever you're going to write is the code in the generator block. What this generator actually do is it will generate the values which are called as transactions. Okay, transaction is nothing but packet of data. So what is this packet of data means? For example, if you have seen this 3-bit adder, you are taking three inputs A, B, C, like from 0, 0, 0, 0, 0, 1, so on up to 1, 1, 1. So this is called my packet of data. Okay, this is called my packet of data or transaction. Either of these, both are same, like either packet of data transactions. So now the generator will generate these transactions randomly by using the randomization technique. Got my point? Yes. So this is what it is happening here. The generator will be generating the transactions by using the randomization technique. Okay. So now what is happening? You are not manually doing anything. The generator is based on the law, based on the code that you are writing. Okay, I will also explain you how you are going to write the code within all these blocks. You don't worry about that. Okay, so generator will be generating the packets of data which is called as transaction, and it will generate it and it will send to the driver. Okay, now what will the driver do? Okay, for example, now the driver will be driving the inputs that it is receiving from the generator to the DUT. Okay, that is what the work of the driver. So when the generator is generating the transactions, they are in the normal level. Like for example, I am giving 2 plus 2. Okay, the generator is giving two packets of packet of data called like 2 plus 2. Now this 2 plus 2 is converted into pin level. Pin level is nothing but binary level by the driver, and then it is given to the DUT. Got my point? Through interface. Okay, so this is what that is being done. Okay, let me just repeat you one more time. So generator will be generating the packets of data and it will be sending to the driver. Now what will the driver do? The driver will convert that packet of data to pin level, which is nothing but binary level, binary format like zeros and ones, and then it will be giving it to the DUT with the help of interface. Okay, you won't see this interface in Verilog. You won't see any of this in the Verilog. Okay, now with in DUT what is happening? Okay, just like you are sending it to DUT by manually sending, here instead of manually doing it, the generator will be writing given it to the driver, then giving it to the DUT. Okay, now what happens? The DUT will be convert, like it will be working, the values will be worked on the logic, and then the DUT will send that information to the monitor. Okay, so got my point? Through interface only, again it will send it to the monitor. Just like what does the dollar monitor do in your Verilog test bench? Here it will be monitoring all the outputs that is sent by the DUT. Got my point? Here now the monitor, what it will do, it will be monitoring all the values that is coming from the DUT, and then it will be sending that transaction packets to the scoreboard. Okay, so now the scoreboard is a place where what it will be happening is it will be comparing the actual in actual output versus okay, expected output. Okay, so what is this actual output versus expected output? Means actual output means the transaction that it is received from the monitor, that is called as actual output. Expected output means what we are expecting from the DUT. Okay, so what that DUT is sending is called as actual output. What we are expecting from DUT is called as expected output. So now those the scoreboard, it will be comparing these two values, like is actual output and expected output same or not. And if that is not same, then again what it will do, it will be taking the necessary measures, like there is some bug in it, so it will be checking like everything. Okay, so this is what happening. Now all these components, if you see generator, driver, monitor, scoreboard, all these are packed within the environment, right? So now the environment is again packed within the test bench. Okay, test cases. Okay, so these test cases are nothing but, for example, you are designing a memory. Okay, this is because it is just a 3-bit adder. Okay, it is not it just only what it will do, it will be taking the outputs and it will be giving to DUT and the logic is performed and it is given fine. But if you move a bit further, like you are designing a memory, okay, so in memory there are many cases, like you should read the memory, you should read memory into one register, you should write memory from one register. So all these things happen. So these are considered as test cases. Test case is nothing but what are the cases that you want to test. So you want, in case of memory, what are the cases that you need to test? You need to test whether the reading is done, and you need to test whether the writing is done properly with for the memory. Is it or not? So these are the two test cases you need to check for the memory case. Okay, in the similar way, for any other design you are going to design, there may be some test cases for designing. Okay, so the test cases are nothing but whatever you want to test for that particular design. Okay, all these are considered as test cases in SV. Okay, so this is the test cases, and the test cases will be within the like test bench top. You will be having the test bench top also here. Okay, in the top what you will be writing, you will just be instantiating everything, like in as just like in Verilog you will be instantiating RTL and TB, you will be instantiating all these blocks within the test bench top. Okay, clear. So this is about the test bench architecture. Okay, now you may get doubt that in in Verilog, if you see, you don't need all these things for simple adder. Now you may get doubt that this is very huge compared to that of Verilog, and for simple adder, do we need to do this much? No. For if you are if you have limited your idea to only add a subtract and counters or something, you don't need this much big system Verilog structure in order to check all these things. Okay, but I am telling you about the real time field where you will be designing a circuit. Okay, so designing the circuit includes very more lot more components than you imagine. Is it or not? So when we are going to design such complex circuits, okay, this Verilog, as I told you in the previous class, is not uh, used, is not efficient because of its limited nature. Okay, so that is why this test bench architecture is designed in system Verilog. And also, test bench architecture is really important. It is just the heart of the system Verilog. I could say that. Okay, so don't miss this out. So listen to test bench architecture carefully, and after listening to it, if you are having any doubts, you could ask me in LinkedIn, or else you could ping me in the comment box. I will definitely reply you. Got my point? So this is about test bench architecture in system Verilog. Okay. So this is just a basic thing. Okay. Now if you see in this test bench architecture, this generator, driver, monitor, okay, not interface and DUT. Okay. Apart from these two, like scoreboard, everything are class based. You should remember that. That means you will be writing the codes within this generator, driver, monitor, whatever you're going to write the code within these blocks, everything should be class based. Okay, that is what I said. Why everything should be class based? Why? Because if you see in this, class is dynamic in nature. Okay, so class properties are dynamic in nature. Because of the dynamicity nature of the class, it is mostly used for reusing purposes. Okay, how we are going to reuse it and all, we will be seeing once we go to the deep of these topics. But class is, because of the nature of dynamicity in the class, we will be using everything in a class. Okay, but DUT is nothing but it is module based. Okay, since it is RTL, is it or not? DUT is nothing but device under design under test. So design under test is module based. And interface, it is interface again. You will be it is just a separate topic you will be learning with in SV. This topic also I'll be explaining that about this interface. Okay, but as for now, if you really are enthusiastic in what is interface means, it is in order to make you understand in a simple way, I could say it as a it is similar to bus. Okay, so bus is what we will do. Bus is nothing but it's a group of wires. Is it or not? A group of wires. It will be formed in. It is in the form of a bus. Similarly, group of inputs and outputs. For example, if you are seeing this SV adder, okay, you are having A, B, C inputs. Okay, so all these A, B, C inputs are packed within this interface and it is sent to the module. Instead of sending from driver to module in a different like A one time, B one time, C one time. Okay, if you're having many more inputs, all this instead of sending all this individually, I have just packed them in the form of interface and I'm sending it to the DUT. Similarly, this packed interface only it will be coming to the monitor. Okay, just a brief idea on what is interface. It is similar to bus. Okay, so this is test bench architecture. Now let us see. So transaction, what is this abstraction of all signals that are present in DUT? Nothing but if you are taking the full adder, this A, B, C, all the signals are nothing but transaction. Transactions are just a signals. Okay, A, B, C inputs. Okay, like 0, 0, 0, 0, 0, 0, 1, 0, 1, 0. So this packets of data is nothing but transaction. Okay, now coming to generator. This component generates different input stimuli for the DUT. What is this stimuli? Stimulus is nothing but a data. Okay, the packets of data we will call it as a stimulus. Now the generator will be generating these packets of data, okay, for the DUT in order to send them to the DUT. Right now, driver, what this component will do? This component drives the various signals according to the stimulus generator by the generator. Okay, that means whatever that is whatever that is generator is generating, whatever stimulus that is the generator is generating, it will be driven to the it is generated. It will be driven. Okay, driven to the monitor, like sorry, it will be driven to the DUT, okay, by the driver. Now what does the monitor do? This components monitors the input and output signals and samples them at some event. Okay, this sample signal is compared with the reference output. What is the meaning of this sampling thing? Because here, as I already told you, the driver will convert the stimulus to the pin level. Okay, now, whatever that is received from the DOT, it will be in this pin level only. Pin level is nothing but it will be in the binary format. Now, the monitor will be again converting this pin level to the normal format. That means it will be sampling them, and this sample signal is then. That means the normal output is then given to the comparison to the scoreboard. Okay, this sample signal is compared with the reference output. Reference output is nothing but, as I told you, in scoreboard you will be having expected output. Okay, this expected output is also called as reference output. So what does the monitor do? It will be sampling that signals and it will be giving them to the scoreboard where it will be compared with the reference output. Okay, this component is responsible by comparing the sampled packet with the reference one. That is what I told you. Sampled packet means what it is. It is, we in normal words, it is the actual output. Okay, and the reference one is nothing but the expected output. So it will be comparing, and if there is any mismatch between actual output and expected output, then the necessary measures will be taken. Now, what does the environment do? Environment encapsulates. What is encapsulation? I think you already know. Okay, just a simple word like capsule. Okay, you'll take capsules. Okay, what does the capsule do? It will be hiding something inside it. Okay, that means all will be packed within that, all the medicine will be packed within the capsule. Okay, similarly, encapsulation is nothing but everything is packed within the environment. If you see in the test bench here, okay, all these components are packed within the environment. So, that is what environment is. Clear? So, this is about the test bench architecture, right? In the next session, we will be talking about data types in system Verilog. Okay, you are having many more data types compared to that of Verilog. Okay, along with Verilog data types in the study session, I have already told you when I am speaking about differences between Verilog and system Verilog, you are having many advanced data types in case of system Verilog when compared to that of Verilog. Okay, so don't miss that particular thing, right? So if you are new to my channel, consider subscribing my channel and hit on the notification bell also, and also follow me on all the social media places that I have given in my YouTube channel, right? So thank you for today. That is all.